A machine smaller than your hand is quietly reshaping the world. Every AI chatbot, image generator, and self-driving system depends on chips like these. NVIDIA did not start as an AI company. It began with gaming graphics. However, one unexpected discovery changed the entire technology industry forever. Engineers realized that the same processors designed for video games could train artificial intelligence. And this is where everything changed. Within months, companies around the world began competing for NVIDIA chips. Some customers were waiting years for deliveries. But the hardest part was still ahead. Before a chip can power AI, it begins as a nearly perfect disk of silicon. One tiny defect here can destroy millions of dollars of production. At temperatures hotter than lava, a giant silicon crystal is slowly pulled from molten material. This process can take several days without interruption. The crystal is sliced into wafers thinner than a fingernail. However, what happens next requires some of the most advanced machines ever built. This machine costs more than a luxury skyscraper. It uses extreme ultraviolet light to carve.
Billions of transistors are now taking shape.
Now the impossible begins. Layers only a few atoms thick are added with astonishing precision. Some coatings are thinner than a single strand of DNA. One uneven layer could silently ruin everything built so far.
Then powerful plasma removes material atom by atom. However, this isn't destruction. It's the birth of billions of microscopic electronic pathways.
Each transistor is almost unimaginably small. Together, billions of them will soon think faster than entire supercomputers from just decades ago.
The engineers aren't wearing protective suits to protect themselves. They're protecting the chips from something much more dangerous: humans.
One tiny speck of dust can be larger than entire sections of the circuitry. That's enough to destroy a chip worth thousands of dollars. Now every layer is inspected. Thousands of high-speed cameras search for defects invisible to the human eye. And this is where everything changes. Ironically, artificial intelligence is now helping manufacture the very chips that will power future AI systems. The factory is becoming smarter every second. After weeks of flawless manufacturing, a defect suddenly appears. It measures only billionths of a meter. This wafer survives one of the toughest manufacturing stages on Earth. But wait until you see what comes next. Weeks of manufacturing have led to this single moment. One cut too deep, and millions of dollars disappear forever. Hidden inside a single wafer are hundreds of future AI processors. But surprisingly, not every one of them survives. Every chip is examined one by one. Even the smallest imperfection means instant rejection. Perfection isn't the goal, it's the requirement. Now begins one of the hardest engineering challenges. Building the chip itself was only the beginning. Thousands of invisible connections now link the processor together. Miss just one, and the world's fastest AI chip becomes completely useless. But here's what almost nobody knows. The processor isn't the fastest part anymore. Its closest partner, HBM memory, is just as critical. Instead of spreading memory across a circuit board, engineers build it upward in towering microscopic stacks. It's like constructing a skyscraper. Instead of spreading memory across a circuit board, engineers build it upward in towering microscopic stacks. It's like constructing a skyscraper in...
Everything you've seen so far was only preparation. For the first time, this processor finally resembles the AI.
But speed alone isn't enough. These processors must survive temperatures that would overwhelm ordinary computer hardware.
Engineers deliberately push every chip to its limits. Because a failure here is far better than a failure inside a billion-dollar AI data center.
Some processors run for days without stopping. Hidden weaknesses often appear only after hours of relentless operation. But the next decision is even more surprising. Even perfect chips aren't identical. Some perform slightly better than others, and those tiny differences determine where each processor will be used. A modern AI processor can consume astonishing amounts of power. Without advanced cooling, it would overheat within moments. One powerful GPU is impressive, but connecting many together creates something entirely different. For the first time, individual processors become part of something much larger. Every connection brings the system closer to powering the next generation of artificial intelligence. This is where the journey truly begins. These processors no longer sit alone. One server is powerful. Thousands working together become an AI supercomputer, capable of solving problems once thought impossible. Every second, these chips help move oceans of information across the planet. But demand is growing faster than anyone expected. Building one AI chip isn't the work of a single factory. It depends on an extraordinary supply chain stretching across multiple continents. A single delay at any stage can ripple across the entire industry. However, the greatest challenge isn't manufacturing, it's keeping up with demand. Long before these systems reach customers, they've already traveled thousands of miles, and many are reserved months before they even leave the factory. These processors aren't just training chatbots. They're accelerating medical research, scientific discovery, robotics, and technologies that could transform everyday life.
Builds. Every new generation raises the stakes. Each breakthrough promises more speed, more efficiency.
The chip you've seen today may already be surpassed by the one engineers are secretly building next. Everything you've witnessed so far has been building toward this moment. But the biggest question isn't how these chips are made. It's the chip you've watched being built isn't the finish line. Inside research labs, engineers are already designing processors that will make today's AI hardware look primitive. Each new generation packs even more computing power into nearly the same space. Engineers continue shrinking technology toward physical limits once believed impossible. Perhaps the greatest irony is this: artificial intelligence is increasingly helping build the processors that will create even more powerful artificial intelligence. Tomorrow's processors may move information using light itself, unlocking speeds that today's electrical connections simply cannot reach. Tomorrow's processors may move information using light itself, unlocking speeds that today's electrical connections simply cannot reach. Researchers are exploring entirely new ways to compute. Some ideas may redefine computing itself, but turning them into practical machines remains one of engineering's greatest challenges. Every breakthrough inside a clean room eventually reaches the outside world, powering discoveries in science. The real impact of these chips isn't measured in billions of transistors. It's measured in discoveries, breakthroughs, and the problems humanity may finally learn to solve. Just minutes ago, this was a silent piece of silicon. Now you know the extraordinary journey hidden inside every advanced AI chip. Every smart system, every powerful model, and every future breakthrough begins with engineering on a microscopic scale. From raw silicon to one of the most advanced machines ever created. This journey is a reminder that the future isn't built by magic. The technology inside one AI chip is extraordinary, but it's only one piece of the puzzle.